What is fire? Sounds like a child's question. It's not. Because here's what most people believe. Fire is stuff burning. Wood catches flame. Paper ignites. Fuel plus oxygen equals heat. Simple chemistry. That belief is not a little wrong. It's fundamentally wrong. Fire isn't a thing. Fire isn't even burning. Fire is light escaping. Every flame you've ever seen, candles, campfires, your gas stove, is photons fleeing from excited atoms. Electrons jumping between energy levels and screaming their identity in color. The yellow of a candle, that's sodium atoms confessing. The blue at the base, carbon monoxide giving up its secret. You're not watching destruction. You're watching atoms broadcast their fingerprints at the speed of light. And here's what nobody tells you. Scientists can look at any flame, any fire in the universe, and know exactly what's burning. Not by touching it, not by smelling it, by reading the light. This changes everything you thought you knew about flames, about color, about how we decoded the entire universe. Let me show you. Grab a candle, any candle, or just picture one. That little teardrop of light sitting on your dinner table. Peaceful, simple, obvious, wrong. Look closer, not at the whole flame, at the structure. See that dark zone right above the wick? No light there, nothing glowing. Why? Now look at the blue at the base, then the orange in the middle, then the yellow at the edges. 3 different colors, one flame. Here's the part nobody tells you. Those aren't just pretty colors, those are atomic signatures. Each zone is running at a different temperature. Different molecules are breaking apart, and each one is releasing photons at a specific wavelength. The flame isn't one thing, it's a layered light show, organized by physics, choreographed by chemistry. People say fire is burning stuff, but that's just a label. What's actually happening? The wax melts. It travels up the wick. It vaporizes. The vapor molecules break apart. The atoms get excited. And when I say excited, I mean electrons are absorbing energy and jumping to higher orbits. But here's the thing. They can't stay there. The universe keeps strict books. An electron in a high orbit is borrowing energy it can't keep. So it falls back down. And when it falls, it pays back the debt. In light, that's the flame. That's what you're seeing. Not burning, not destruction, refund. In photons. Every color in that candle is an electron returning what it borrowed. Specific atom, specific jump, specific color. Think about what just happened. You looked at a candle your whole life and saw fire. Now you see a debt collection agency. Beautiful. So electrons jump. They fall. They release light. Simple enough. But why specific colors? This is where your intuition fails. You'd think an electron could release any amount of energy, any color, a smooth rainbow of possibilities. Nope. Electrons are picky, brutally picky. They can only exist at certain energy levels. Think of it like a ladder. You can stand on rung 1, rung 2, rung 3, but you cannot stand between rungs. Impossible, forbidden. The universe doesn't allow it. So when an electron falls from rung 3 to rung 1, it releases a very specific amount of energy. That energy becomes a photon. That photon has a very specific color, not roughly specific, exactly specific, exact. This isn't preference, it's accounting. And here's what this means for fire. Every element has different rung spacing. Sodium atoms have their ladder. Copper atoms have theirs. Potassium has a completely different one. So when you burn sodium, electrons fall down sodium's ladder. You get yellow light, that exact yellow, always. Burn copper, electrons fall down copper's ladder. Green light, that exact green, always. Hold that thought. This means the color of a flame isn't random. It's a confession. The atoms are telling you who they are. Let me say that again. The color is the identity. You don't need to analyze the material. You don't need to run tests. You just need to read the light. Now here's the thing. Do this right now. If you have a gas stove, go look at it. See the blue flame? That's carbon and hydrogen atoms releasing photons as they combine with oxygen. Specific atoms, specific jumps, specific blue. Now sprinkle some table salt into that flame. Boom, yellow, bright, intense, unmistakable. That's sodium, the same sodium in your salt. You didn't change the fire. You added new atoms, new electrons, new confessions. The flame doesn't lie. It can't. Light doesn't negotiate. People say flames are just hot gas, but that's just a label. What they really are, a parade of electrons returning borrowed energy. each return stamped with an atomic signature. The flame is a receipt, a record of exactly what's being torn apart. And scientists figured out how to read those receipts over 150 years ago. That discovery changed everything. Germany, 1859, two scientists, Robert Bunsen and Gustav Kirchhoff, working in a small lab in Heidelberg. Bunsen had just invented something, a burner, clean flame. Barely any color of its own, the Bunsen burner. You've seen it. Every chemistry class has one. But here's the thing, Bunsen didn't care about the burner. He cared about what happened when you put stuff into the flame, different substances, different colors. Every single time, Kirchhoff was the physics guy. He asked the dangerous question, what if we don't just look at the colors? What if we separate them, spread them out, see exactly which wavelengths are there? So they built a device, a prism, a slit, a way to split the light. And here's where it gets strange. They didn't see smooth rainbows. They saw lines, sharp, bright, specific lines at specific positions. Wait, each element produced its own pattern. Sodium made two bright yellow lines, always the same position, always the same spacing. Hydrogen made a different pattern, completely different lines. Lithium, potassium, calcium. Every single element had its own barcode. Think about what just happened. Fire became a fingerprint reader. You could burn anything, anything. Look at the lines. Know exactly what atoms were inside. No touching, no chemistry, just light. Kirchhoff realized something wild. If hot elements emit specific lines, maybe cool elements absorb those same lines. He was right. The sun, that giant ball of fire in the sky. It has dark lines in its rainbow, missing colors, gaps. Those gaps, they match element fingerprints exactly. The sun contains sodium, hydrogen, helium, iron. Helium was discovered in the sun before anyone found it on Earth, named after Helios, the sun god. We knew what stars were made of by reading their light, not by traveling there, not by collecting samples, by understanding that fire is atoms confessing reality doesn't issue refunds without receipts. And light is the receipt. People say we can't know what stars contain, but that's just a label. We've known for over 150 years. Fire told us everything. Let's play a game. Imagine fire was just burning, just heat, just oxidation, just chemistry doing chemistry things. If that were true, every fire would look the same. Think about it. Wood fire, paper fire, gas fire, candle fire, all just fuel plus oxygen plus heat. Same process, same reaction type, same result, right? Wrong. Look at fireworks. Red, green, blue, purple, gold, silver. Spectacular, precise, controlled. How? Different metals. Strontium gives you red. Barium gives you green. Copper gives you blue. Not because they burn differently, because their electrons live on different ladders, different rungs, different jumps, different light. Here's the part nobody tells you. Firework designers don't mix colors like paint. They mix atoms. They choose elements based on electron behavior. That red isn't dye. It's strontium electrons falling from one specific orbit to another. The green isn't pigment. It's barium atoms confessing their identity. Wild. Now think bigger. What if all fire was just burning? What if the color meant nothing? Forensic scientists couldn't identify accelerants at crime scenes. Astronomers couldn't determine what stars are made of. Steel workers couldn't monitor the purity of molten metal. Everything would be guesswork. But it's not guesswork, because fire isn't just burning. Fire is information. The universe keeps strict books. Every atom must declare itself. No exceptions, no forgeries. You can't fake a flame color. You can't trick the electron ladder. Burn sodium, get yellow, always. Burn copper, get green, always. This isn't chemistry class trivia. This is how reality enforces honesty. The flame cannot lie. So far we've learned this. Fire is light escaping. Color is atomic identity. And every flame is a forced confession. But how do we use this? Steel mill, somewhere in Germany, 3 in the morning. Molten metal glowing at 1500 degrees. Orange, blinding, liquid death in a giant vat. A worker points a device at the surface, not a thermometer, something else, a spectrometer. It reads the light, not the temperature, the light. And in seconds, It tells him exactly what's in that metal. Carbon content, chromium levels, impurities, no samples, no weighting, no lab, just light. This is where your intuition fails. You thought fire was primitive, ancient, the first technology. It is, but also it's the most advanced detection system we have. Here's how it works. The spectrometer captures the glow, splits it into wavelengths, reads the signature lines. Every element screaming its identity at 1500 degrees, in real time, quiet, powerful. This isn't theory. This is Tuesday at a steel plant. Now zoom out, forensic labs. A fire investigator finds accelerant residue. They burn a tiny sample. Read the spectrum. Gasoline has a signature. Diesel has another. Kerosene something else entirely. The flame tells them what started the fire. Brutal. Medical labs. Doctors analyze blood samples using flame emission. Sodium levels, potassium balance, read directly from light. Your blood telling secrets through fire. Here's the thing. Do this right now. Look at your phone screen. See those colors? Red, green, blue pixels. Those are specific wavelengths, chosen because your eye's electrons respond to them. The whole system is wavelength accounting, from steel mills to your pocket. Same principle. Light doesn't negotiate. People say technology has moved beyond fire, but that's just a label. We're still reading flames. We just got better instruments. Fire isn't ancient history. Fire is current technology, and we've barely scratched the surface. Look up tonight. Every star you see is fire, not poetic fire, actual fire, nuclear fire. Atoms fusing, electrons jumping, photons escaping. And here's the thing. We know what those stars are made of, not guessing, knowing. How? Same trick, same principle, same confessing electrons. The light from a star travels millions of years, crosses unimaginable distances, enters a telescope, hits a spectrometer, and we read it. Hydrogen lines, helium lines, carbon, oxygen, iron, all there, all confessing. Think about what just happened. You're sitting on a rock, floating in space, looking at a fire burning 4 light years away, and you know what's in it. Beautiful. Here's where it gets stranger. We can tell if a star is moving toward us or away by reading the light. The lines shift slightly, measurably. Moving toward us, lines shift blue. Moving away, lines shift red. The universe keeps strict books. Even motion gets recorded in light. This isn't preference, it's cosmic accounting. Now zoom further. Galaxies, billions of light years away. Ancient light, older than Earth. We read their fire. We know what they contain, how fast they're moving, whether they're dying or being born, all from light. People say we can't know the distant universe, but that's just a label. We've read the receipts. The universe mailed them to us at the speed of light. Every photon is a messenger. Every flame is a confession. From the candle on your table to a supernova exploding before dinosaurs existed. Same physics, same electron ladders, same honesty. Fire isn't local. Fire is universal, and it never stops talking. So far, we've learned this. Fire is light escaping. Color is atomic identity. Every flame is a forced confession. And this works everywhere in the universe. Now, here's the reframe. Fire isn't destruction. Fire is communication. Let me say that again. When something burns, it's not disappearing, it's speaking. Every atom in that flame is broadcasting, sending out photons, declaring exactly what it is, what it was, what it's becoming. The wood isn't dying, it's transforming. And during that transformation, it tells you everything. This is the part that changes how you see the world. You thought fire was violent, chaotic, dangerous. It is. But it's also the most honest thing in the universe. Humans lie, instruments fail, data gets corrupted. Fire cannot lie, the electrons must fall, the photons must carry specific energy, the color must match the atom. No exceptions, no forgeries, no negotiation. The constant is enforced. Here's the deep truth. When you look at a flame, you're watching matter confess under pressure. Energy goes in, identity comes out. That's not destruction, that's revelation. Think about it. Every campfire, every candle, every star, a confession booth, atoms stepping up, declaring themselves, then transforming into something else. Wild. People say fire destroys things, but that's just a label. Fire translates things from matter into light, from solid into story. The wood becomes warmth, and photons and information. Nothing disappears. It just changes language from atoms to light, from stuff to signal. Fire is the universe's translator, and now you speak the language. So, next time you light a candle, next time you sit by a campfire, next time you see flames dancing in a fireplace, remember, you're not watching destruction, you're watching confession. Atoms declaring their identity, electrons paying their debts, photons carrying messages across the room, across the planet, across the universe. The same physics that lets you read a candle lets scientists read stars. The same light that warms your face told us what the sun is made of. Fire doesn't burn. Fire speaks. And now you understand the language. Here's my question for you. Go light a match. Tonight, look at the color. Really look. Yellow, blue, orange. What atoms are confessing? What electrons are falling? What message is the flame sending? Drop your answer in the comments, because I want to know. What do you see now that you couldn't see before? The universe has been talking this whole time. Fire was never destruction. Fire was always the message. You just learned how to listen.